Hi everyone. So today we will discuss another Leetcode problem. So this is known as maximum subarray. So in this Leetcode, this is known as a maximum subarray. But if you see the same problem in Coding Ninjas platform, then the same problem is known as maximum subarray sum. And if you see the same problem in gigs for gigs, this is known as gigs for gigs ZFG platform, and the same problem is given as largest subarray sum. So don't get confused by this naming convention. These are the same problem. So let's see this problem, what does it say. So yeah, so given an integer array nums, find a contiguous subarray containing at least one number which has the largest sum and return its sum. So a subarray is a contiguous part of an array. So if you see the example 1, what is given, one input array is given here, 2 1 minus 3 4 minus 1 2 1 minus 5 4. These are the elements. If you see carefully, the positive and negative both elements are present in this array, right? So we have to return the subarray which sum is the largest. What does it mean? Let me remove this. So we have to return a subarray. The subarray could be like minus 2 1 minus 3, like minus 2 1 minus 3 4. The subarray it's like minus 1 minus 3 4 minus 1 2 1. These are the subarrays, right? So when you do the addition of all this subarray, the element which would be the output from this subarray, which would be the output from this array, and what would be the output from this array, these sum should be the largest sum we have to find out. So how can we do that? Yeah, so now let's see, there are different approaches or different technique to solve this question, but let's see the approaches first, then we will solve using one from that approach. So now we can use what we can apply first. We can apply the brute force technique first. So if you use the brute force technique, then the time complexity would be order of n cube, and the space complexity would be order of 1. For brute force, this would be the time complexity and the space complexity. So another technique that you can use here, that is known as a boundary fix approach. So if you use the boundary fix approach, the time complexity would be order of n square, and the space complexity would be order of 1. So now another approach, this is known as divide and conquer. So if you use divide and conquer approach, then we will get the time complexity to be n log n, and the space complexity would be order of n. There are another approach, this is number 4. So we can use sum array approach. So sum array approach, if you use sum array approach, we will get time complexity would be order of n, and the space complexity would be order of n again. And the last and the most efficient approach, that is known as Kadane's algorithm. So very important algorithm. This is Kadane's algorithm is a very important algorithm, and most frequently asked question from this algorithm in the interview. So if you use the Kadane's algorithm, this will give us order of n time complexity and the space complexity would be order of 1. So now these are the 5 techniques or approaches. Today we will see to solve this question using the Kadane algorithm, because it is the very important and efficient technique to solve this question by looking at the time complexity and the space complexity. Alright, so now let's take the example and jump into our solution. So now we have to take one array. So let's take the array. Yeah. Let's take the example array. What is given? This is given. My bad. Yeah. Okay. So the array is given like this one. Okay. -2, 1, -3, 4, -1, 2, 1, -5, -5 and 4. How many elements are there? Total 9. So index would be 0, 1, 2, 3, 4, 5, 6, 7, 8. So 9 elements are present in this array. So now see, in the first iteration, what we will do, it will start from 0th index. We will take 2 variables. The first variable is known as the sum or the current sum you can take. So what is the current sum? Current sum we will fix the current sum is 0, and we will take maximum. So maximum sum would be integer dot mean value. So integer dot mean value will give us a highest minimum value. I forgot this. That is negative number. Anyway, let's check this approach now. So for I equal 0, what would be our current sum? This is the I equal 0, 0 plus -2. So what we will get? We will get -2, right? So what is the maximum amount so far? This is the maximum. So now after calculating the current sum and the maximum so far, we have to check another condition, whether sum is less than equal 0 or not. If it does, then our updated sum would be 0, right? So these are the steps to follow. So what I have told, quickly recap it. Now we will be taking one current sum value. That current sum is this one. I have taken as a variable sum. So this current sum would be initially 0, right? When we iterate in the 0th index of this array, the value in the 0th index is -2. We will add this -2 with the 0. 0 plus -2 is -2. What would be our maximum so far? The maximum so far would be -2, and we are now checking whether the sum is less than equal 0 or not. The sum is less than equal 0 because we'll get this -2. We got the -2. That's why -2 is less than 0. That's why the sum equal 0 now. Current sum is 0 now. Alright. So now go to the second element or the second index. So now see, again do the sum. What are our current sum? 0. What is the element present in the first index? That is 1. 0 plus 1, 1, right? So what would be our maximum? If you see the maximum, -2, from -2 and 1, the maximum of -2 and 1 is 1, right? So our maximum will be updated to 1. Now make this 1. Alright. So now for I equal to repeat the same steps. Our sum equal 1 plus -3 that would be -2, then max would be 1, and here see our sum is less than 0, that's why the sum equal 0. So this would be our updated maximum subarray. So after this, again go to the third iteration, I equal 3. What would be our current sum? Current sum 0 plus 4. This is the updated sum here, so that's why it will come 0 plus 4. 4 is the third index element. 0 plus 4 will be 4. Then what would be our maximum? If you see the initial the updated maximum for this step is 1, and now we got 4. If you find the 1 and 4 maximum, then we will get maximum will be updated to 4. So for our array is this one, this is the maximum. So now go to the fourth iteration. So for I equal 4, see our sum is, current sum is 4 plus -1, then it would be 3, the maximum would be 4. So now maximum subarray is 4. Alright, so now for I equal 5, what would be our current sum? This would be 3 plus 2, then 5, then maximum 4 and 5 is 5. So the subarray is our 4 minus 1 and 2. The index should be 3, 4, 5. Alright, so for 6 index, 6 iteration, the sum would be 5 plus 1, it will give us 6. Our maximum is 6, so our maximum subarray would be 4 minus 1, 2 and 1. The index would be 3, 4, 5 and 6. So for again go to the 7th index, the sum would be, I hope you are following me. I am not explaining everything because the steps are same. So I'm just doing the calculation here to check whether we will get the maximum subarray sum or not. And this would be our 4 minus 1, 2, 1, should be 3, 4, 5, 6, and the last step would be I index I equal I 8, sum is 1 plus 4, that will give us 5. Our maximum would be 6, so our subarray is 4 minus 1, 2, 1. The index would be 3, 4, 5 and 6. So we are done with our calculation as we have reached the last index. So now see what we got. Our maximum sum we got is 6, right? And the subarray is, and the maximum subarray is this one, 4 minus 1, 2, 1. Alright, so this is the Kadane's algorithm. So now let's go to the coding part, right? So let's go to, so this is the very basic coding of Kadane's algorithm. So as I told, in the current sum, first of all initially we have taken 0, and our maximum sum in the initial, this should be our integer dot mean value. So we'll be iterating or traversing every elements in the subarray, and we will add those elements in the current sum, and then we will check this current sum is greater than maximum or not. If it does, then we will update our maximum sum to current sum. And lastly we will check if current sum is less than 0 or not. If it is that, then we will update our current sum to 0, and lastly we will return the maximum sum. So as I discussed, the time complexity for this algorithm is order of n, and the space complexity would be order of 1. So that's it. This is the algorithm, and I have gone through all these steps while doing this dry run, and I hope it's clear for you. All the best then. All right, thank you so much.